Hi guys, so we're going to go over your Unit 6 exam review worksheet. All right, let's do this. Number 1, based on the normal model for car speeds on an Old Town highway. Remember this notation, this is my mean and this is my standard deviation. And that tells me that it's based off of a normal distribution. That's why we have that capital N there. It says what's the cutoff value for the highest 15% of speeds. So for reference, we're looking at a normal curve centered at 77 with a standard deviation of 9.1. And I want to know this upper boundary, the lower boundary actually, for the upper 15%. Remember that your calculator only reads to the left. So when I insert this into my calculator, I'm going to use inverse norm because I'm looking for a particular value. The area to the left is 85%, so 0.85. Mean is 77, standard deviation is 9.1, and you should get out D, approximately 86.5 miles per hour. Number 2, for a recent English exam, use the normal model, mean 73, standard deviation 9.2, to find the percent of scores under 58, round to the nearest tenth of a percent. So now we're looking at a percent of scores. So what we're doing is we have a normal curve centered at 73 with a mean of with a standard deviation 9.2. And we want to find the percent of scores under a particular X value, which is 58. So I want to know the percent of scores less than 58. When I want to know a probability under the curve, I use normal CDF in my calculator. My lower bound, this is for the probability of X being less than 58. My lower bound is something large and negative, like negative 1,000 or 10,000. My upper bound is 58, mean of 73, and standard deviation of 9.2. You should get approximately E, 5.2%. All right, 3. At everyone's university, 25% of the students wear contact lenses. We randomly pick 200 students. What is the probability that more than 28% of the sample wear contact lenses? Okay, this is categorical data since we're talking about whether you wear contact lenses or not. So for this particular example, you're going to get that pi, and therefore mu sub pi, is equal to 0.25. And the standard deviation is going to be 0.25 times 0.75 over n, and n is 200. You should get out approximately 0.031. And I want to look at the probability that a proportion is more than 0.28. So I'm going to be looking at an area under the curve using normal CDF, lower bound of 0.28, upper bound of 1,000, mean of 0.25, and standard deviation of 0.031. You should get out approximately B, 0.164. All right, number 4. The weights of the fish in a certain lake are normally distributed with a mean of 13 pounds and standard deviation of 12. All right, so this mean and standard deviation are for all fish in that lake. So these are population parameters that we have right here. If 16 fish are randomly selected, that means I have a sample of 16. What's the probability that the mean weight will be between 10.6 and 16.6? So we're looking at a probability here because we're looking at an area under the curve. But one thing we need to do is we need to adjust sigma to be for the sample, which would be 12 over the square root of 16, which happens to be 3. Remember, mu is equal to mu sub x bar, so I don't have to really do anything to that. So my lower bound is 10.6, upper bound 16.6, mean of, this is 13, not 12, my apologies, 13, and standard deviation of 3. And you should get out approximately 0.673, which is E. Okay, and for number 5, in a survey of 1,000 television viewers, 40% said they watch network programs. For a 90% confidence level, the margin of error is 2.5%. If we want to be 95% confident, how will the margin of error change? Okay, so one thing that you need to remember that's very important about confidence intervals is that the larger the confidence, the larger the interval. Okay, and so that's kind of the answer we're looking for here, and that would be option B. Since more confidence requires a wider interval, the margin of error will also be larger. Remember, your margin of error is half the width of the confidence interval, so they change together. Question C. The weights of a random sample of 43 male high school students were recorded. The mean weight was 152 pounds with a standard deviation of 15. Okay, so one thing that needs to be noticed is we're going to check our conditions first. So my first condition is the sample random? And it's stated that it's random, so we're going to say stated. Second condition, is it normal? And since 43 is greater than 30, by the central limit theorem, the sample distribution is approximately normal. Number 3, is sigma known or unknown? This standard deviation of 15 comes from the sample of 43 males, not from the population, so sigma is unknown. And step 4, 43 is less than 10% of the population. Okay, so what we're doing here is we are building a t interval since sigma is unknown and we have numeric data. Remember your formula is x bar plus or minus t star s over the square root of n. How do I find that t star value? I'm going to use inverse t. I want 98% confidence, so remember that means I have 98% confidence with 1% on each side. So if I want to find this upper bound critical value, it's the full area to the left, so 0.99, and degrees of freedom are n minus 1, which would be 42, giving us a critical value of 2.42. All right, so I can plug all in the information I have in here. X bar is 152. Plus or minus t star we found to be 2.42 times s, which is 15, over the square root of n, which is 43. You could compute this out to be approximately 146.46 and 157.54. So now, of course, we're going to interpret this in context, and that is we are 98% confident the true mean weight of high school students, I guess they're male students, is between 146.46 and 157.54. Make sure you show all of your work. Your answers may be off a little bit, but if you show your work, you're good to go. Part B says, what sample size would you need to cut the margin of error in half? Okay, there's a couple of things you need to know in order to get this question correct, okay? Okay, remember your margin of error is half the width of your confidence interval. So if I want the width of my confidence interval, I'm going to take 157.54 and subtract 146.46. That gives me 11.08. This is my current confidence interval width. In order to find my margin of error, I'm going to divide this by 2 and get 5.54. This is my current margin of error, my current width of the margin of error. And I want to cut that margin of error in half. So I'm going to divide it again, and I'm going to get 2.77. So this is my new allowable margin of error that I am accepting. So I'm going to use my formula. B equals, remember Z stars or T star is not going to work out right here because I don't know what N is. I'm solving for N. So I have to substitute in a Z star for that, and that's okay. In order to find my Z star value, I'm going to use inverse norm, 0.990 and 1, and I get out 2.33. All right, we're going to plug in everything we know here. So my margin of error is 2.77 equals Z star, which is 2.33, times S, which is 15, over the square root of N. And you're going to solve, and you should get that N is approximately 159.20. So approximately 160 people need to be in my sample in order for my margin of error that I have above to be reduced even further. I need to up the sample size. So this may be different depending on how you rounded. It's important that you have this step right here for me. If the mean and standard deviation were actually for all male high school students, what would be the probability of getting a sample of 20 with a mean weight less than 145? So all we're going to do is we're going to just adjust our information to fit a sample of 200, okay? So let's do this. My mean is still 152, and my standard deviation is 15. So my standard deviation of the sample is 15 over square root of 43. Or not 43, I'm sorry. We changed the sample size to 20. Okay? Which is approximately 3.35. And I'm looking at the probability of a mean weight less than 145 pounds. So I'm looking at normal CDF. A lower bound is something large and negative. 145 is an upper bound. A mean of 152 and a standard deviation of 15 over root 20. And I will get out approximately 0.018. So there is a 1.8% chance of getting a sample of 20 students with a mean weight less than 145 pounds. Okay? Okay, here we go. 2,000 randomly selected Americans were asked if the minimum wage should be raised. This is categorical because your answer to this question is yes or no. It's not a numeric response. So 1,350 of them said yes. Check your conditions, then create and interpret a 90% confidence interval for the true proportion of Americans that want it raised. All right, so let's check this out. So I've got to find my proportion here, and my proportion is 1,350 over 2,000, which is 0.675. Let's check the conditions. Number one, is it random? Yes, it's stated. 2, n times p is less than or equal, or greater than or equal to 10. So 2,000 times 0.67 is greater than or equal to 10. Number 3, 2,000 times 1 minus p, which is 0.325, is greater than or equal to 10. Please check out. And step 4, 2,000 is less than 10% of the population. Okay, so we're good. I want a 98% confidence interval. This is a 1 proportion z interval. So I'm going to say p plus or minus z star times the standard deviation and plug in everything I know in order to do this. Okay, so my p-value is 0.675. Plus or minus that z star we've calculated before, or you can memorize it, is 1.645. Standard deviation is 0.675 times 0.325 over n, which is, in this case, 2,000. And you should get out 0.6578 and 0.6922. So we are 90, how much percent? 90%. 90% confident the true proportion of Americans that want minimum wage raised is between 65.78 and 69.22%. All right. What size sample would you need to have 95% confidence to within 2%? Okay, remember your formula. B equals Z star times the standard deviation. All right, your Z star, we want 95% confidence. You could have already calculated this or had this memorized. Our margin of error is 2%, so 0.02 equals 1.96 times 0.675 times 0.325 over n. And we're going to go ahead and solve for n, and you get n is approximately 2,107 people. This is somewhere where you really want to make sure you show your work, because based off of how you round, your answer could look differently. Last question. Suppose the above proportion is actually for the population. What is the probability of getting a sample of 200 people where less than half want to raise the minimum wage? Really, this is just a distractor question. This is just telling you that mu is equal to 1,350 over 2,000 still, which is 0.675, but that your sigma sub x bar is going to be the square root, or sigma sub p, sorry, is going to square root 0.675 over 0.325 over 20, or 200, which is 0.033. So when I'm looking at the probability of a proportion being less than 50%, I'm going to use normal CDF, negative 1,000, something small and negative. 0.5, my mean is 0.675, and standard deviation 0.033, which gives you 5.707 times 10 to the negative 8. So there is approximately a 0% chance that in a sample of 200 people, less than half will want to raise minimum wage. All right, one thing to remember when completing this assignment and getting ready for your test is you need to make sure you always check your conditions and make sure you use that table of formulas that I gave you, because it's really important. If you identify something is categorical, then you follow those categorical conditions. So the first question you always want to ask yourself is the data numeric or categorical? Once you determine categorical, you're good to go. Follow those steps. Once you decide it's numeric, you ask yourself, is sigma known or sigma unknown? And based off of that, you follow the next steps. Either way, that's a really important part. All right, you guys, I'll see you tomorrow. Good luck.